So here we are at problem 3F from the summer packet. We notice that we have the limit as x approaches -6 of this particular expression. And, normally we try direct evaluation, but immediately we can see, oh, we're probably going to end up with that 0 on the bottom. So instead, actually use to kind of simplify this. So another one that we kind of try and go to is to factor and see if anything can simplify. You could pull a 2 out there, but it's not really going to be able to cancel out with anything. So that's not really going to be necessarily the route we want to take. You can't even really factor this guy evenly, at least. So we're actually not going to even use factoring. Instead, kind of the fail-safe, and honestly, a lot of the times you're going to end up doing this when you see these rational functions, especially with these kind of like multiple pieces, like you have one here and one here, is actually doing that foo. So we're going to go ahead and multiply this left side one by x over x, and we're going to multiply the one on the right by that x squared minus 12 over x squared minus 12. Because again, when you do foo, you're not changing at all the original. When I say original, I mean the original expression. You're just changing the way it looks by multiplying that foo. So, I know I've stressed that a lot in a lot of my classes, so definitely make sure you're pretty comfortable with that foo. Now, let's go ahead then and distribute the top. So we have x times 2x gives us 2x squared. Still have the limit, I should say, as x approaches -6 of 2x squared plus 8 times x, so just 8x. On the bottom, I usually like to actually just leave it, so we have x times that x squared minus 12. So not actually distributing that in, and then minus. Now 1 times that x squared minus 12 is just going to be that x squared minus 12. It's really important to have that parenthesis around there too, because you are going to be distributing that negative to both of them. So you can have the parentheses, or you can go ahead and already distribute that. It's up to you. On the bottom, though, same deal. You're just not going to distribute in, so you just have x times x squared minus 12. All over, again, that x plus 6. So now that they have the exact same bottoms on the top fraction, we can for the top fraction. We have 2x squared minus x squared. Nothing can be combined with this 8x, so we still have plus 8x. And then really we have minus -12. So in other words, you're just really adding 12. On the bottom, we still have that x times x squared minus 12. And again, this is all over that x plus 6. So now at this point, we have a fraction. This is considered to be just the one fraction over really a bottom fraction. Because so what I'm going to do is actually rewrite not changing it. And then instead of that big division bar that we see right here, I'm going to go ahead and actually change that to a division symbol. They mean the exact same thing, just changing the way it looks is all. And then on the right of that, we still have that x plus 6 over 1. So again, that red line means exactly the same thing as this black and green line. Now the reason why we would do that is so that we can actually, the limit as x approaches -6, running to black, so we still have x squared plus 8x plus 12 all over x times x squared minus 12. And anytime you're dividing by a fraction, you're going to go ahead and change that to multiplication and then you're going to use the reciprocal of the one that is your second one, so this guy. So we just end up then with 1 over x plus 6. You guys have maybe heard of that as multiplying it by the reciprocal. So I know I've said that quite a few times in Algebra 2 if you've had me. Now let's go ahead then and try and simplify this thing. Well, nothing can really cancel out. Even if you just kind of look at things, really this guy over here is the only one kind of giving us that issue. Because if you were to try direct evaluation, throw that -6 in there, this is the only guy where you get that 0 on the bottom. So we're hoping that the one with this red arrow, something will cancel with that guy. Well, if we see on top, we have 1 on top and this x squared plus 8x plus 12. None of that matches this x plus 6, so we can't cancel anything out. Instead, though, what we can do is go ahead and maybe factor this guy, this one on top, that x squared plus 8x plus 12. -6. And this actually is factorable. Now, a lot of times the nice thing as you're doing these limits is if you're trying to cancel something like that, and I'm trying to also factor, I probably have a pretty good idea that that factor is going to be that thing that I'm canceling. So as I'm factoring, I already kind of have the idea that this is just x plus 6. I don't really know what it factors out to. I mean, I do know, but I can just immediately kind of say, hey, wait, problems are kind of structured that way such that something will cancel. That one of the factors has to be x plus 6. Well, it actually does factor out to be x plus 6 times x plus 2. But again, some of your factors, some of your harder factors can get a lot more complex. So that's kind of a nice little trick when you start talking about limits. Some harder limits where then we have x on the right, and then we still have times 1 over x plus 6. These end up dropping out now, these x plus 6s. And now you can go ahead and use that direct evaluation. So this is the same thing as saying the limit as x approaches -6 of x plus 2 over x times x squared minus 12. And again, using that direct evaluation. So when we throw in -6, we end up with -6 plus 2 over -6 times -6 squared minus 12. In which case, then that ends up coming out to be -4 on top over -6 times -6 squared is just 36, positive 36, minus 12 comes out to be positive 24. Jumping ahead. And there are various ways that you can actually continue on with this one. To be honest, I think the easiest way is just to say that we're going to make it this positive, because negative divided by negative is just a positive. And then 4 goes into 24 6 times. So we just end up with 1 on top over 6 times 6 is 36. So that would be our limit. And again, that is problem number 3L from the summer packet.